second report «Нанокомпозити для керамічних та гібридних підшипників».
Dear colleagues, let me introduce sorry.
Excuse me, Ostap, I did not
Sorry, yes,
give,
I understand it's.
give
I
knowledge
am
about the
represent
author
the
and reporter.
institute, the Frantsevich Institute for Problems of Material Science. Let me introduce our project about development of nanoceramic and hybrid bearings for several operating conditions. Ceramic and hybrid bearings used in different branches of industries. They used from aviation through transport to clean room equipment. Why nanocomposites? Nanocomposites, as we research and find out, it's 2 times better in mechanical properties, in tribological properties than conventional coarse-grain ceramics materials and composites. And we decide to use these features to obtain bulk nanostructured composites for wear-proof application. In our investigation, we use nanopowders from different suppliers around the world. These suppliers supply a big batches, around a few tons of nanoparticles in batches. We test 2 technologies of consolidation. The first one is spark plasma sintering technologies. It's newly developed technologies, up-to-date technologies, combination of pressure and very rapid heating help us to obtain bulk, fully dense nanocomposites very quickly, and these composites could be very cheaper. We develop the special schedule for SPS equipment in collaboration with our colleagues from Fraunhofer Institute in Dresden, and obtain nanocomposites in form of rings, balls, rolls for ceramic bearings. This is really nanocomposites with average grain size around 50 nanometers. The next technology we use is rate control sintering technologies. These technologies could be used on existing equipment. We use the gas vacuum high temperature furnace to consolidate the nanopowders, nanocomposite powders, only calculate the special schedule for consolidation and obtain nanostructured composites in form of rings, rolls for ceramic and hybrid bearings. Some tribological properties of our materials. We test it in dry sliding contact in pair with steel 100 CR6, in pair with cemented carbide, and in pair nanocomposite. We find out that the best pairs to assemble the hybrid bearings is pair nanocomposite in pair with hard alloy, and much better is pair nanocomposite. You can see it's decreasing the friction coefficient, and after fitting in period stabilize the wear rate of material. Why nanomaterials? We investigate the surface. This one is counterbody, hard alloy. After friction, between surfaces formed the layer of nanoparticles. These nanoparticles work as hard lubricant, and we can use these materials in friction pairs without special addition of lubricant, because nanoparticles is the best lubricant for dry sliding for these materials. We test our materials on stability in acids and alkali at high temperatures and find that these materials is quite stable in aggressive medium at high temperatures. As the market of ceramic and hybrid bearing demonstrate growth 3 or 4% per year, it's very good to investigate in nanoceramics and make ceramic and hybrid bearing. First of all, we orient on Ukrainian and former Soviet Union market, but our materials is comparable in price and in technology in properties, and it means that in future we can see on West Europe market. First of all, we see on materials for sliding application, for sliding bearing application, but possible ball bearing and roll bearing development. We estimate some reference cost for our nanocomposites. We compare a few suppliers and find that the best is best in price is it's a experimental batch of nanopowders developed in Institute for Problems of Material Science. But assembling of nanocomposites, consolidation of nanocomposites from other suppliers is too good, because the price is comparable with other present ceramic bearings on our market. It has to be mentioned that we test two technologies. The first one is spark plasma sintering technology. It could be adapted for industry very quickly, and this technology is not very sensitive to nanopowder quality. Because applied a pressure and high heating rate, we can obtain fully dense nanocomposites very quickly, and we can change suppliers of nanopowders. But the equipment for spark plasma sintering is a little bit higher on price. On the other side, we test rate control sintering technology. It could be easily implemented on existence equipment, on existing facilities. Only needed furnaces, gas, vacuum, high temperature furnaces to consolidate nanopowders. But this technology is very sensitive to the quality of nanopowders. If we change suppliers, or if we supplier change some particle size or chemical content of nanopowders, we have to recalculate the schedule. Maybe we have to make some preliminary operation to obtain nanoceramics with guaranteed properties. Here presented that our materials developed in this project, it's 2 or 3 times better than materials presented on our market. I mean Asian analogs and some analogs from European productions. And these materials could be exploited at extremal condition at high temperatures and in aggressive mediums. We prepare some projects to Horizon 2020, and if you're interested in this technology, or you can go to us. All is comments and groups now formed, and all is welcome in this project. Thank you for your attention.
Thanks.
And
Please, questions?
Sorry, can you return 2 slides before?
No, no.
That's okay. No. To the end.
and
No.
Yes,
this one.
you talked about some economic advantages, but I see this referring cost of your institute 2020, and it's more cheaper. Maybe that's why expenses of nanomaterials cheaper compared to this upper designs.
As this nanomaterial.
Twice cheaper, I see.
It's twice cheaper because this is a project of Dr. Ragula. It's a nano project. It was presented last year, and in this project they produce experimental batches of nanopowders. I calculate the price for 5 grams ring of nanocomposite, and this real price on 2013 year for these nanopowders.
Another questions? On one of the slides, you showed the pictures where you wrote along the X horizontal axis slight distance. But for my, here, yeah, sliding distance, yeah. But for my point of view, the damage depends not only of sliding distance, but also of another component, another material.
It's sliding distance. It means that one material slides on the counterparty. Yes. After the first period.
Excuse me. It depends on the next material.
Yes, it depends. Conventionally used steel. Sheha 15, and we find that it's not very good for nanocomposites. The better to use nanocomposite. It's much stable properties. It's distance, but more correctly will be right the wear rate. Wear rate of nanocomposite. Nanocomposite is equal to 0 after some distance of preliminary sliding. And this material can work 2 or 3 times longer than conventional coarse grade ceramics.
For example, ceramics and steel, yeah?
Yes.
Thanks. Another questions? Thank you very much.